Assalamu alaikum, everyone. So today we're going to start with the question paper. In the last class, we completed all the topics from P1. This is your January 23 P1 paper. We'll try to solve the entire paper in today's class. And also, we are going to have the physics mock today, right? As per the plan, we are supposed to have the physics mock today at 11 p.m. Bangladesh time, which is going to be 8 p.m. for Arif in that case. And which means that tomorrow you guys will have to do your maths mock, right? Maths mock will be at the same time, 11 p.m. Bangladesh time. Okay. Now if we start with the first question, this is what they're only asking to simply differentiate it, right? This equation, you just have to differentiate and give your answer in the simplest format. That means you not only have to differentiate it, you also have to simplify it. So over here we have the part A. Y is equals to 2 plus 10x power half and then minus 2x power 3 over 2. If I differentiate this, then obviously I can understand that this 2 in front will become 0. And eventually you will have this half multiplied with 10, half minus 1. And again, this 3 by 2 multiplied with 2x 3 by 2 minus 1. Eventually, now you have half multiplied with 10, leaves you with 5 x power minus half, and also this 2 and 2 cancels out, leaving you with minus 3x power, how much? 3 by 2 minus 1 is just 1 by 2. Right, so you can write this in this format, or you can also keep it in this 5 root x minus 3 root x, right? So this is your final equation for the gradient also, you can say, because in the next point again they're asking that find the exact value of the gradient of the tangent to C at the point where x is equals to 0, and you should give your answer in the simplest format again. This time you have to understand that this was actually the equation for a curve, and curve is always parallel to your tangent. If curve and parallel is parallel to your tangent, that means gradient for your curve is equals to gradient for your tangent. From your part A, the equation that you got for dy by dx, dy by dx, this is actually the equation for the gradient. Okay, this is the equation for the gradient of curve C. If you just want to find out the curve, find out the gradient of this equation when x is equals to 2, I just have to input what? F prime 2, right? I just have to insert that x-axis value into this equation, and that leaves you with 5 root 2 minus 3 root 2. Over here also they're asking you that you have to find out the exact value. Exact value means that your answer should be in the surds format. Okay, that is your hint over here. If I want to write this directly in the calculator, they would give you answer in the decimals format. So I cannot use the decimals format. They're asking you to keep your answer in the surd format, and that's what they refer by the exact value term. So for this exact value, what I can do is that maybe I can do LCM over here. So we have 5 minus 3 root 2 root 2. Eventually root 2 means 2 divided by root 2 multiplied with root 2 divided by root 2, rationalization to eliminate the root, and eventually 5 minus 6 is just minus 1, right? So we have minus root 2 divided by 2. So you can finally write minus half root 2 as your final answer. This is the gradient of the curve or of the tangent at the point when x is equals to what? 2, right? This is the final answer. Is there any problem for this point?
No, miss.
Anshat, Arif, any problem from part B?
No, teacher.
Okay, then 1 minute, please. Okay. Then moving on to your next question, it says that point.
Could you go a bit up?
Yeah, sure.
Um, okay, you can go down.
Okay. Then question 2, it says point P, Q, and R have these three coordinates. This is P, Q, R, and we need to prove that angle PQR is 90 degrees. Okay, 1 minute. PQR, they are saying that this angle is 90 degree. If this angle is 90 degree, that means I can clearly understand the gradient of PQ and the gradient of RQ. Their product is going to be -1. So I just have to find out the gradient of PQ first. So gradient PQ. Gradient PQ, we have 11 minus 7 and then 9 plus 3. So eventually you get 11 minus 7, 9 plus 3, which is 1 by 3. And then again, you have your gradient QR. So this is going to be 2 minus 11 and 12 minus 9. So you get -3. So you just have to say that MPQ and MQR, and that leaves you with 1 by 3 multiplied with -3, and eventually you get -1. So this is your part, right? Over here, you can also say that also. I mean, this is only enough. Like the gradient, product of the gradient of the lines PQ and RQ end up getting -1. That is your final answer. That yes, therefore, angle PQR is actually equals to 90 degrees, right? So this is your final answer for part A. This is how you proved it also. And lastly, they are saying that given that is such a point that on PQRS, this is a triangle now, and you need to find out the coordinate for the X this time. So I can clearly understand that if this is a 90 degree, that means a similar triangle will be forming on the other side also. And I just have to find out the coordinate of that Q, so of that P in that case, right? So S is S in that case. Opposite of P,
Teacher, wouldn't
yes.
y be -3? Yes.
For which one, sorry?
For S, for value of S,
Oh,
since
value of
P,
S.
yeah, so since P is, sorry, my bad, 7, my bad. Wouldn't the y coordinate for S be 7?
To be honest, over here, this is not exactly a diagram that I have drawn to the original coordinate, right?
No. I'm just mentally saying because
Yeah,
if P
it
and
should be,
Q,
right.
no, sorry, my bad. P and S is a straight line, so the
It
y
should have
coordinate
the
should be the
same,
same, right?
yes, it should have the y coordinate same value. The problem is that it's not, it might not be a straight line because as you can see also, R and Q, they were also in a straight line in my diagram because this is just a rough diagram. I did not draw the exact coordinates here. So this
Yes.
is not how we can predict the coordinate of your X, right? If I was, maybe drawing this exactly to the coordinate on a graph paper, then you can easily find out from the graph paper that over here, how many coordinates you have? 3, 7, right? -3, 7, maybe it would be somewhere here. Then again, the next value was at 9, 11. 9, 11. 9, 11 is somewhere over here, maybe. Then again, you have 2, 12, right? So this is how the coordinates of the triangle are going to be, or the rectangle is going to be. Now, you can clearly understand that this is not entirely what you can say is a straight rectangle, right? Since this is not a straight rectangle, then I cannot predict the way you were trying to find out the y coordinate of S. That was prediction. We cannot apply it over here. Okay, so if I just remove this, and if I want to find out the x coordinate and y coordinate for both S, without your help of your, what was that, without the help of your predictability, we can understand the coordinate for your S. What I can understand even from the rough diagram is that PS is going to be the equal length of QR, and PQ is going to be the equal length of RS, right, or SR. We're going to use this length calculation to find out the x and y coordinate for this, what was that, coordinates of P. Okay, now for your coordinates of P, we have 3, 1 minute. Or, I can also consider that this point is actually the intersecting point of line PS and RS, right? We can also think of it in this way, that PS is actually the intersecting point of the line PS and RS. This is where they are going to intersect. So this idea also I can use over here. First, let's find out that we already know the gradient of PQ was what? Gradient of PQ was 1 by 3. If the gradient of PQ was 1 by 3, then I can easily write down the equation for RS. Equation for RS uses the gradient for PQ. So equation for RS over here, gradient is going to be 1 by 3, and I can use any of the coordinates. For RS, I obviously have to use the coordinate for R, which is coordinates are 12 and 2. So now if I want to find out the coordinate, y minus 2, 1 by 3, x minus 12. 12 divided by 3 ends up getting 4. So you have y 1 by 3, x minus 4 plus 2. 1 minute. 12 by 2. So 12 by 3 is minus 4. Plus 2 is going to be minus 2. So this is one equation that we got. And again, if you want to find out the equation for PS, for PS, I have to use a gradient of PQ because, sorry, RQ. Yeah, for this one is parallel to PS. So we have to use the gradient for QR. So we have the gradient here as minus 3. If this is minus 3, then and also the coordinate over here, I'm going to use a coordinate of P, which is minus 3, 7. So minus 3, 7. And here we are going to use the equation y minus 7 minus 3 x plus 3. So eventually you have y minus 3x and minus 9 plus 7 is going to be minus 2 again. So now this is your second coordinate. I can understand that equation 1 and equation 2, they both intersect at point S. So I just have to insert equation 1 into 2. So we have 1 by 3 x minus 3 and then again minus 3x minus 2. So if you write all the x's together, 1 by 3 plus 3x and 2 minus 2, this was actually 2. 2 minus 2 are going to cancel each other out, leaving you with 0. So eventually you will get the value for your x is also 0, right? If the value for your x is 0, then you just have to substitute x equals to 0 into any one of the equation. I'll just substitute this into equation 2. So you end up getting minus 3, 0, minus 2. So that is minus 2 in that case. So the final coordinate for S is actually 0, minus 2, right? This is your part B calculation. Is this clear?
Yes, miss.
They're only giving you 2 marks for this. So, you don't have to show all the working for equation 1, all the working for equation 2. You can just directly write. I mean, you can just, if you want to skip the working, you can over here because they're giving a very small mark for this maths. So the only marking points are going to be writing the equation for line 1, writing the equation for line 2, and finally, you just have to do the substitution to find out the coordinates for x and y, right? The only marking points are equation for line and 1, line 2. Otherwise, anything doesn't over here contain any mark. Arif, Anshat, any problem from both of you?
That's clear.
Anshat, are you still in class?
Yeah, no problem.
Okay, then if we move on to question 3. This is what simple integration. We did this in the last class also, right? I have to just separately divide the numerators with the denominator now. So we have 4x power 5 divided by 2x square plus 3 divided by 2x square dx integration. So eventually I'm going to get how much? 4 over 2 is 2. X power 5 minus 2 is 3. So you get 2 x power 3 plus 3 over 2 x power minus 2. And then now it is all simplified. We can now start the integration. So you have 2, 3 plus 1 divided by 3 plus 1, and then 3x power minus 2 plus 1, and then again 2 multiplied with minus 2 plus 1 plus c. This is a normal integration, so obviously I have to write a c over here. So we get 2 divided by 4, which is just going to be half x power 4, and then again this one is going to be what? 2 plus minus 2 plus 1 is just minus 1, so this one becomes minus 3 over 2 x power minus 1. That means obviously this, it belongs to the denominator, and this is your final answer, right? 1 by 2 x power 4 minus 3 by 2x plus c. I hope there is no problem from integration. Let's quickly move on to your question 4. It says that where k is a non-zero constant, no real roots, find the range of values of k. No real roots means that this time they are saying that this is a complex root situation, right? Wait. Yeah, complex root situation. If this is a complex, oh no, for no real roots means that uh, and no real roots is complex root situation. Yeah, no real roots means complex root situation. That means it actually doesn't intersect with your x-axis. If it's not going to intersect with your x-axis, then your b square minus 4ac is actually less than 0. So you get, I mean, from here I can understand that the value for your a is k, b is 6k, and c is 5. So from this, that no real roots, we understand that discriminant here is going to be b square minus 4ac less than 0. If this is the case, then the value for your b is 6k whole square minus 4, 5k less than 0. So you have 36k minus 20, this is square, 20k less than 0. From here, I can write 36 and 20, right? I can take 4 as a common factor. Yeah, I can take 4 as a common factor, so it will be 4k. So I have 9k minus 5 less than 0. So we get either 4k less than 0, which eventually leaves me with the value for k is less than 0. And the other value is 9k minus 5 less than 0. So from there, I end up getting 5 over 9. It was already stated that this is a non-zero constant. That means over here I got a non-zero gradient, or sorry, zero range. So I'm going to cancel this out. I'm going to cancel this out, and we're going to only accept this k, oh wait, non-zero constant. But yeah, I mean, actually I can also accept this. But my ranges are not going to be exactly this. My critical values are going to be this and this. For the critical values, from the critical values, I can clearly understand the what was that, my range also. My quadratic equation that I got is your positive quadratic equation less than 0, right? Positive quadratic equation less than 0 means they're talking about this portion of the calculation. So for this portion of the calculation, we have how much? 5 over 9 and 0. So 5 over 9 is moved to the left, right? This range obviously falls to the left of 5 over 9 and to the right of 0. So we can finally write this as 5 over 9 less than 0. And this is your range of values of k. Is there any problem from this question 4?
No, miss.
Obviously, the graph doesn't have to be plotted. That is just a rough. I only draw that over here so that you guys can understand what exactly, how do we find out the range. Otherwise, the rough work was not required for this maths. Okay. Then if we move on to your question 5. Question 5 is about then what? Middle term stuffs, right? They are saying that we have to substitute 3 power, p as a value for 3 power x in this equation. Before we do the substitution, this 3 power x plus 2, it indicates actually 3 power x was multiplied with 3 power 2. So from there we get actually 3 power 2 is 9, and then 3 power x, which is going to be 9p in that sense, right? Again, for the 3 power x minus 1, this actually indicates 3 power x multiplied with 3 power minus 1. Now 3 power minus 1 is 1 over 3, and then 3 power x. So we get 1 over 3p. So this is what we get for this 3 power minus 3 power x minus 1 and 3 power x plus 2. For this 9x also, if I want to split it down, 9x actually refers to 3 square then x, right? So I can write also this as 3x square. So eventually you're going to get as p square. So for the final case, if we start with 3, 9x equals to, plus 3 power x plus 2, and then 1 plus 3 power x minus 1. I can already understand that it's going to be 3p square. 3x plus 2 was 9p, and this is 1, and this was 1 over 3p. So from there, I can write this as 3p square, 9p minus 1 over 3p minus 1, 0, and we get 3p square, 9 minus 1 over 3, we get 26 by 3p minus 1 equals to 0. Oh, I have to do an LCM here because I have to write my answer in this format. So if I do the LCM, we have 3 multiplied with each term. So 3p square, then 26p minus 1, 3 equals to 0. So you eventually get 9 minus 3, 0, right? So this is your final equation. Up to part A, we were only asked to solve this one. Other than this, we're not asked to solve anything else. Sorry guys, just wait for a minute. Okay, so this is it. We are done with the shown part, and for this next part, we just have to do middle term over here, right? Hence, solve this. So in order to solve this, we have 9p square plus 26p minus 3, 0. Can anyone find me the factors of this equation? What are the roots for this equation? Use your calculator and try to find out the roots for these equations.
1 by 9 and minus 3.
Okay. In that case, 1 by 9 and minus 3 means I have to multiply 1 by 9 with 9. That gives you minus 1 by 9. So it gives you minus 1. And then again 9 with 3, that gives you 26, right? So 27, sorry. So I just have to split 9p square plus 27p minus p minus 3, 0. So from there, I can take 9p as a common factor. So we get p plus 3 minus 1 as a common factor, p plus 3 is 0. And eventually I can write 9p minus 1 and p plus 3. From there, I get 9 as equals to the values that you got from your calculator. But now originally in the equation, they didn't have p, right? They had x. So I have to now replace the p with 3 power x. 1 by 9 as that is actually 1 by 3 square. And in one line, if I write, it will be minus 3. And this time we have 3 power x minus 3 power 0. There's a problem over here. The minus sign actually doesn't mean that they are both equal. So this cannot be equal. I cannot get any value from there, but I can get a value of x from this side. Over here, the indices are matched, the bases are matched with each other. So they will cancel each other out, leaving you with the value for x as minus 2. Other than that, this is the only value that I get. This value will not be accepted. So this is your only answer. Is there any problem from question 5, A and B?
No, teacher.
Okay, if there is no problem, then let's quickly move on to question 6. Question 6 about is your radian measures and what was that? Cosine formulas, right? Cosine rule. Now it says that the figure 1 shows the plane view of the design of a stage, and the design consists of a sector OBC of a circle with center O joined with two congruent triangles OAB and ODC. It is already given that angle BOC is 2.4 radians. Before doing this maths, you have to make sure your calculator is always converted into radian mode. And area of the sector is given also as 40. AOD is a straight line of length. AOD is a straight line of length 12.5 centimeters. If this is 12.5 centimeters, and I can clearly understand that O is at the center, that means AO and OD are going to be half of that length, right? I'll write this as 12.5 centimeter first. This is your 24 radian, or say 2.4 radian. And lastly, the area here is 40 meters square, right? Then other than that, we don't know anything. I exactly do not know if they are also 90 degrees or not, right? Because it is not stated here. They have said that okay, this triangle and this triangle are congruent, but I do not have any idea about that till now. So first they want to find out the area, so radius of the sector. I can easily find out the radius of the sector using that area calculation. So for part A, area was given as 40. The area formula is always half r squared theta 40. So eventually you're going to end up getting 40 multiplied with 2 divided by your 2.4 radians divided by entire and everything under the root. So root 80 divided by 2.4, you end up getting 5.77 meter. The exact value that you get is 10 by 3 root 3, or you can say you get 5.77 meters, right? Okay, then after this, they're also saying that find the size of the angle AOB in radians to two decimal places. For AOB, they're asking. AOB means this one. I can clearly understand that if this is your 2.4 radian, and this angle and this angle, AOD and DOC. So AOB and DOC are of equal length. If this is theta, this is also theta. So theta plus 2.4 is going to give you 1 pi. So we can write for part B, theta plus 2.4 is equals to pi according to the sum of a straight line base, or theory, sum of a straight line. You don't need to write this, by the way, okay? I'm only writing the explanation for your revision. Like whenever you come here for the revision, you can understand this. Why am I doing this? So you get pi minus 2.4 divided by 2, which is going to be 0.37. So this is your answer, 0.37. You could have also written over here that what is the theta. I mean, on the diagram, you obviously wrote that, but if you want to write that in your as a part of your maths, you can also do that. That over here, angle AOB and DOC both are considered as theta, assumed as theta for your part B calculation. After this, they're asking you to find out the total area of the stage, giving you answer in meter square to one decimal place. For the total area, I already know for the sector we have 40. I just have to find out the area of my AOB and DOC, which again I can clearly understand. I have to use a formula half AB sine theta, right? Because this value and this value is given. A radius came out to be 5.77. If the total length is 12.5, 12.5 divided by 2 means that this one is 6.25, right? So we can write this down for your part C, that AO is actually half of 12.5, which is 6.25, and not just AO, DO is also equals to AO, right? They're both of equal length. And if I want to find out the total area of the sector or total area of the, what was that? Stage, total area of stage. In the total area, we have two triangles of same dimensions. So basically, for one triangle, I will be doing 1 by 2, 5.77 multiplied with the 6.25 multiplied with sine 0.37. Right, this will be multiplied with a 2 because similar triangle was present 2 times. So that's why we multiplied 2 with this. And then we're going to add this with 40 area for the sector. So we have 5.77, then your 6.25 and sine 0.37 plus 40. You get 53.04. I mean, if I would, use the answer, this will actually give me a proper value, an exact value I will receive. Then I should write this as 10 by 3 root 3, then multiplied with 6.25, then sine 0.37 plus 40. So actually, the rough answer that I get from here is actually 53.04. They have asked me to keep your answer as one decimal place. So in that case, I get 53.0 meters square, right? Because I get 0.4, so I can only write 0 meters square. Other than this, I actually don't get anything else. Then again, after this, wait 1 minute. 10 by 3 root 3, 6.25, then sine. So I'm getting 53.07. In that case, 53.07, after you round that up, you're going to get 53.1 meters square, okay? And you can also, instead of using 0.7, you could have also used pi minus 2.4 divided by 2 to get an accurate value for this area calculation, right? As this was the value that you got for the theta, or fraction for the theta, pi minus 2.4 divided by 4. So this is your total area. And after this, they're also asking the total perimeter of the stage to one decimal place. For the perimeter, I can understand that, yes, we have this 12.5. We can easily find out the arc length using that r theta value. But for this AB and CD, I have to use the cosine rule over here, right? Yeah, I have to use a cosine rule. So first, for part D, in order to find out either AB or CD, I have to use a cosine rule, which is 5.77 whole square plus your, what was the other length? 5.77 whole square plus 6.25 whole square minus 2 5.77 and 6.25 cos 0.37, then again everything will be inside a square root. So if you're going to write 5.77 square plus 6.25 square minus 2 5.77 6.25 and cos 0.37, you are going to get 2.26 for this AD and CD, so 2.26 meter. Finally, for the total perimeter, the length associated here are your AB plus CD plus your BC, the arc length, and finally AB, right? So AB is 2.26, CD is also 2.26, BC is actually the arc length, which is just r theta, 2.4 multiplied with 5.77, and AD was given as 12.5. So this multiplied with 2 plus 5.77, 2.4 plus 12.5. So you get 30.869. You can approximately write 30.9 meter as your final answer for the perimeter. Is this clear? Any problem from this entire question 6?
No, miss.
Anshat, Arif, any problem from this part?
No, teacher.
Okay, if there is not a problem, then we'll move on to question 7 quickly. For question 7, this is about a fraction graph or something, right? They're asking you to draw the sketch for the curve y is equals to 6 over x. I already can understand that they will never intersect with the x or y axis because both x and y axis is acting as their asymptote. So I just have to draw them. They've already provided me with the space. So one curve on the positive quadrant or on the first quadrant, and then again a similar type of curve will be formed in the third quadrant as well. Right, so this is your graph for y is equals to 6 over x. Now after this, they're only giving you, I think, 1 mark for it, so no need to do any workings or anything over here. After this, they're saying that this is your graph again. Now describe the transformation here. Okay. I can understand that, this minus 2 is only associated with your x, right? Yeah, I mean, if f of x was your 6 by x, then now it got transformed to f x minus 2, which is now is your 6x minus 2, right? So from here only your x-axis got modified. In this graph, we didn't had any x-axis. The graph never intersected with the x-axis. But now we can understand that in this situation, why they never intersected with the x-axis, because their asymptotes were x equals to 0. Over here, this asymptote will be shifted to x plus 2, right? Because this time the vector is how much? Minus 2 means the vector is actually 2, 0. So you just have to add this 2 with the x-axis. So or the asymptote now becomes 2, and asymptote now becomes 2. For the only horizontal asymptote now becomes 2, but the vertical asymptote, so this is the vertical asymptote, that will only become 2, but for the horizontal asymptote, which was y equals to 0, that will remain as y equals to 0, because there we didn't have any vertical translation. It was just horizontal translation. So I have to not also explain this. I mean, I do not actually have to write down this over here. I just have to explain that this is a translation of 2 units to the right on the x-axis, right, or parallel to the x-axis. That's what I just have to say. So for your part B, this is a rough working that you can do. You don't have to do all the rough working. They will never give you any mark for the rough working. But the actual word that you have to say is that this indicates a translation of 2 units to the right parallel to the x-axis. parallel to your x-axis. And then again after this, for your part C now, it says that this graph is going to intersect with this straight line where k is a constant, and they intersect exactly at 2 points P and Q. Exactly at 2 points means they have two coordinates, and the x coordinate of P is already given as -4. We need to find out the value for your k. Okay. I can clearly understand this is your equation 1 and this is your equation 2. If I'm going to substitute 1 into 2, then this is how they're going to look. Kx plus 7 is equals to 6x minus 2. So if you simplify it, so you have kx squared minus 2k minus 7x minus 14 equals to 6. So eventually you can write this as kx squared minus 2k, sorry, minus 7x, and minus 14 minus 6 is going to be minus 20. So you get, I'll just write, minus 2k minus 20, 0, right? Now they have also given that they are going to intersect 2 times, right? But yeah, I mean, if I just insert that value, that this is equals to 0, but 1 minute. $16K we have, and then minus 7 minus 4. Okay, if I, 1 minute, if I want to simplify this, kx plus 7 and then 6 divided by x minus 2. So we have kx squared minus 2x minus 14 and minus x, right? Oh, sorry, this is supposed to be plus x and minus 14. That was my mistake actually. Now if I insert the value for x equals to minus 4 into this equation, so you have 16k, because minus 4 whole square gives you 16k, minus 7, positive 7 and minus 8 is minus 28, minus 2k, minus 20, 0. So you have 14k equals to 48. So eventually 48 divided by 14, yeah, 2 into 7 is 14. And 2 into 7, 14 minus 6, minus 14 minus 6 is minus 20. Minus 28 minus 20 is minus 48, and 16 minus 2, that's going to be 14. 48 by 14. Okay, let's do this as a simplified process, 1 minute. Without simplifying it, first I can just introduce the 4 into the equation at this stage also. We have minus 4k plus 7 equals to 6. Minus 4 minus 6 gives you minus 4 minus 2 gives you minus 6. So basically you have minus 4k plus 7 equals to minus 1. So if you just take this, minus 4k minus 8 to the right hand side, you're going to get minus 8, and then eventually k becomes 2, right? Minus 8 by minus 4 leaves you with the value for your k as 2. This was a much simplified process. So you get the value for k as 2. After this, they're now asking that you now use algebra to find out the coordinates of q. Obviously, for the coordinates of your q, I can understand that this time the substitution equation was actually 2x plus k 7 and then 6x minus 2. So now if we just rearrange it, 2x plus 7 and x minus 2 equals to 6. So now you have 2x square minus 4x plus 7x minus 14 minus 6 0. So you can write this as 2x square plus 3x minus 20 0. I just have to now middle term this, factorize this. So I get what? 4 as a common factor here, right? Because we have 20 and 2. So if I take 4, that's going to be 8. 4 into 2 is 8. That means the rest of the other factor is going to be 5. So we can write this as 2x square plus 8x minus 5x minus 20 equals to 0. From there, I can write 2x x plus 4 and minus 5 x plus 4 equals to 0. From there, I can write this as 2x minus 5 and x plus 4 equals to 0, which leaves me with the value for x as 5 over 2 and x equals to minus 4. I can clearly understand I'm not going to continue with minus 4 because this was already given as the x coordinate of P, and we want to find out the coordinate of Q. So I'm just going to substitute this x equals to 5 over 2 into our equation 1, which was y 2x plus 7. So we get 2 5 over 2 plus 7, and that is 12. So the final coordinate of your Q is actually 5 over 2 and 12. Is there any problem for your part C and D calculation?
No, miss.
Okay, if there is no problem, then let's quickly move on to question 8 also. Question 8 is about inequalities, and then what is 9? 9 is about your translation, right, for the tan graph. And then 10 is about finding the equation, I think, intersecting points and everything. And 11 is your integration, right, integration. Okay, for this one, it says that figure 2 shows a sketch of a straight line and curve C. Given that L cuts the x-axis at minus 12 and cuts the y-axis at minus 12 and x-axis as 4. Find an equation for L giving your answer in the form of y equals to mx plus c. So from this minus 12 and 4, I can already understand that we have two coordinates available, right? Which is your minus 0 minus 12 and 4 0. From here, if I want to find out the gradient for line L, gradient for line L is going to be 0 plus 12 and then 4 minus 0. So eventually end up getting 3. And we already know the value for your C. Y-intercept over here was already 12. So the equation for your line is going to be y is equals to 3x minus 12, right? I can directly write this using the format of a straight line. Y is equals to mx plus c. This is all the working you need to do for your part A. For part B, now they have given you a big information that given that y is equals to fx, where fx is a quadratic expression that we can see on the graph again. We can also see that this quadratic expression in the straight line intersect when x is equals to 4. And the minimum point of this quadratic equation is already given, 7 minus 18. And it cuts the x-axis at 4 and k, where k is a constant. We need to find out the value for your k. For that value for your k, we first have to calculate the equation for your straight line, right? So since they have given you that the gradient is 7 minus 8, 7 and minus 8, so not gradient, the turning point is given as 7 and minus 8. Which is going to be 7 minus 18. So you have your y plus 18 and 1 minute, y plus Oh, I can write this as y a x minus 7 whole square minus 18, right? I already know this is how I can write down the equation for your, what was that? Equation for your straight lines, equation for your curve using the completing the square method, right? So this is one format of writing this. The other format of writing this. Oh, another thing, if they're asking to find out the value for k and they're giving you 1 mark, that means you have to use symmetry over here actually. If they are provided that that is what was that minimum point was exactly at 7, that means exactly if the minimum point and this first critical point is 4, right? The distance between the minimum point and critical point is 3. If this is 3, then this part is also going to be 3. The other distance from the critical point, the minimum point is also going to be 3. So from that sense, this is going to be 10 actually, right? 7 plus 3, that becomes 10. So you just have to use symmetry here to find out the other critical point where the graph intersects with the x-axis. So for part B, you don't actually need to do this. Maybe it will be required for your part C or something. But for part B, if you want to write something, then you can say that distance of minimum is equal, and if they are equal in that reference, k becomes 7 plus 7 minus 4, right, which is basically 10. So that's how you get the value for your k. Now after this was everything you need to do for part B actually. After this, now they're asking to find out the equation for your fx. You have to now find out the equation for your fx. So this is what we're going to use. Now I understand this is one of the format that we can use to write down the value for your equation. And the other format to write down the value for your equation is y is equals to a. The critical points were x plus 4 and x plus 10. It's going to be x minus 4 and x minus 10. This is one format and this is other format. So I can just now substitute the equations to find out the value for your a here. Yeah, I can do that. So we get I mean, if I just substitute 1 into 2, because both the equations refer to the same graph. So obviously I can write that we have a x minus 4 and x minus 10, and then again a x minus 7 whole square minus 18. Over here we have a x square minus 10x minus 4x, so minus 14 plus 40, and then again you have a x square minus 14x plus 49 minus 18. So you have 31 there, right? So you can write ax square minus 14ax plus 40a, and then again this is equals to ax square minus 14ax plus 31a. 1 minute. We have 18 there, so we get 7 square is 14. Now from here, actually, even if I compare, I'm not going to get any value directly. 1 minute. No, from this substitution method, I won't be able to find out the value for a, like what was multiplied before the completing the square or the roots format also. In that case, what can I do? Oh, there's actually a mistake I made. Over here, A was multiplied with only 7 and up to this whole square, not with 18, right? That's why the answer was not coming as a correct answer. Over here, you are going to write it as, obviously from here, you end up getting ax square minus 14ax plus 40a and minus 18 or plus 18. I'm going to take that to the right hand side, to the left hand side, leaving with 49. And this leaves you with ax square minus 14ax plus 49a. I can clearly see that ax square balances out. Minus 14ax minus 14a balances out. But for the constant, now if we compare constants of this equation, we have 40a plus 18 equals to 49a. So if you write everything, we get 9a equals to 18, like everything, every a to the left hand side, and eventually you get the value of a as 2, right? 18 over 9 is going to give you 2. That means the final equation for the curve C is going to be 2x minus 7 whole square plus minus 18. You can choose to write your answer in this format, or you can also simplify this for the final case. If you simplify this, you're going to get 2x square. 2 4 2 7 is 14. 14 multiplied with 2 is 28x. And then again, 49 with 2 is 98. Minus 98 minus 18 is going to be minus 116. So this is your final equation for the curve. Is there any problem from part C calculation? Fayad, Arshad, Arif, any problem?
No.
Okay, if there is no problem, then we'll move on to your last part. It says that region R is shown shaded in figure R. We just have to describe the inequalities. For the inequalities, I can clearly understand that they are all straight lines, solid line, right? So all the inequalities will have what, greater than equals to, less than equals to, or these values, right? The solid lines always get equals to, and a broken line gets your only less than or greater than ranges. So over here, this the equation for your straight line was y is equals to something 3x plus 12, maybe a 3x minus 12. This was the equation for y is equals to 3x minus 12. For the curve, we also got the final equation as y is equals to 2x squared 28x minus 16. So you can write 2x squared 28x minus 116, and this vertical line is actually x equals to 0, right? Because y-axis is x equals to 0. So I can see that this slant line is above the y is equals to 3x. So obviously as it is above the y is equals to 3x, so inequality is going to be y greater than 3x minus 12. Similarly, for the curve, the region R is below the curve, so we get less than over here, y less than 2x squared minus 28x minus 116. For the vertical line, this is to the right of the straight line, so you get x equals to 0. But instead of x, I will write x is greater than 0 this time, right? X is greater than 0. So this is your values actually. Another thing, yeah, no, actually this is the values, right? X is, so y is greater than 0, and then graph is less than that value, and x is greater than 0. But then another point, it's not like they know that it's falling under entire part of the graph, right? It's only falling under the after the graph or below the graph up to x equals to 4. That means this is also acting as a boundary. X is less than 4 is also acting as a boundary because the region is to the left side of the x equals to 4 value. So we also get x is less than 4. So eventually I can now add this together and write it as x is less than 4 and greater than 0, right? So from there, these are the three inequalities. So this is your working for your part, what? D, I think, right? This is one equation, two equation, and your third equation. Any problem for the inequalities part?
No, miss.
Okay, if there is no problem, then if we quickly move on to your questions 10. Okay, for question 10, it says that y is equals to tan x, and the straight line y is equals to pi x is drawn also over here. In the interval minus pi to pi, find out, state the period of x. We know that in general cases, period of x means what? Period of x means that um, y, so yeah, tan x, right? Between minus pi to pi, this graph is also for the range, right? In the interval minus pi to pi, right? We have to find out the period of x. For the period of x, I can clearly understand this is going to be what? For period of x, this is like, no, total 360 degrees. But one minute, they're giving you 1 mark for this, right? So for this negative pi to pi, like I mean they're asking that first show the period of tan x. I mean for one period, I mean in usual case for cos x, the one period you get 2 pi, right? That is the period for cos x and sin x. And for tan x, you can understand that only this portion and this portion, right? They gave you the value for your one period, right? So this is this part and this part, they both combined give you the value for your one period. So if this is a value for your one period, then this was exactly at pi, and this was at 0. That means the period of tan x is at pi, only at pi, no other values are needed. So period of tan x is just pi over there. And then again, write down the number of roots of the equation where tan x is equals to pi plus 2x. One thing to understand here is they're talking about some translation and translation and stuff. For no, sorry, pi plus 2x means that only the constants are increasing, right? Pi was also a constant, pi plus 2x is also a constant. That will never modify the number of intersection. If over here your tan x is equals to pi x, and there they're intersecting at 1, 2, 3 coordinates. That means for your tan x equals to pi plus 2x, they're going to also intersect at 3 solutions, right? Because this is not any translation. It would be a translation if it was pi x plus 2, or if it was pi x plus 2, right? This would be vertical horizontal translation. But if you're adding 2 with the pi, that is just normal constant, no translation. It doesn't indicate any translation. But tan x equals to pi x within the range of 2 pi to negative 2 pi to 2 pi. Okay, for this one you have to understand that from negative pi to pi, for this negative pi to pi range, for the tan x equals to pi x, you got 3 solutions, right? I mean over here, what was the difference? For 2 pi difference, you got 3 solutions. Over here you have 4 pi difference. Yeah, you have 4 pi difference. For 4 pi difference, you're going to have 2 pi gives you 3 solutions. So in that case, 4 pi gives you 2 multiplied with 4. 1 minute. Within the range, within the interval, negative 2 pi. And this actually gives you 6 solutions. But problem is one solution was exactly at negative 2 pi. If one solution was exactly at negative 2 pi, we cannot accept negative 2 pi here, right? I mean, for example, you can understand that this, 1 minute, tan 90 was there, and tan 90, tan 180. Sorry, 1 minute. Tan 90. Yes, tan 90 is 0. So if this is 90, this is tan 90, and this is where tan 180 is, and 180. Okay, now over here, actually, if I want to find out the solutions, I can, I mean, yeah, over here, this is what happening. In this case, you can understand that exactly at this point also they were intersecting, but they don't have any graphs in this point, right? But for the 2 pi section, what happens? That they will intersect with the exactly at negative 2 pi. If the graph is going to intersect at exactly at negative 2 pi, you cannot accept that value, right? Because over here, the range was not equals to, it was just less than 2 pi, greater than 2 pi. So that's why even if from the unitary solution, you get 6 solutions, you have to eliminate one of the solutions, and that will leave you with 5 solutions. So you're going to get 5 solutions from this tan x pi x equation. And then again, finally, for the same case, you have to find out the interval between the next 100 pi, right? For this 100 pi, what do you have? They indicates 200 pi actually. Yes, they actually indicate 200 pi. You can also do one similarity over here, that for your tan x to pi x, for the pi and pi range, you got three solutions, right? And exactly how many three solutions? One was at the origin, one with the positive value, one with the positive value, and one with the negative value, right? You can just follow the pattern. So in this case, for negative pi to positive pi, you got one positive value, one negative value, and one zero value. That means for your 2 pi to negative 2 pi, over here you're going to get two positive value, two negative value, and one zero value. So that's how you end up getting five solutions. And then again, that's how you end up getting three solutions here. And finally, now if you want to find out that for 100 pi to positive 100 pi, you are going to get 100 positive solutions, 100 negative solutions, and one zero solution. Exactly at the zero, they're going to intersect, and that would give you 201 solution, right? So over here, this is the working for your part 3 or 2 or 1, whatever you say. This is the working for your part B, 2 and 3. Is this clear? Any questions from this part?
No, teacher.
Okay, then we are also done with question 10. Sorry, I think this is 9. Let's quickly move on to question 10. I want to finish this paper today. So over here, this is a graph they have provided. The graph is given as in this format. Now they're saying that using your information, state the values of x for which fx is greater than 0. Okay, I can understand that from this point, the value for your x is going to be x minus 20 by 3, x equals to minus 6, and then again lastly x equals to 3 by 2, right? So for these values, 3 by 2, 3 by 2 is your positive value. This is your 3 by 2, right? This is your 1.5, and the other two values were negative, minus 6 and 20 by 3. 20 by 3 in decimals is actually 6.67, so that means this one will be 6 and this one will be your minus 20 by 3. It was also stated that they want to find out the range for greater than 0. Greater than 0 means that this portion over here will be involved, and this portions are going to be involved. This is your 1.5. These portions are going to be involved. Right, so I can clearly understand for this range, I'm going to write x is less than 6, less than negative 20 by 3. This will come in one set, and the other set is going to be x is greater than 1.5, as it is always to the right of this point value. So this is 1.5. And this is your answer, right? This is the set of range that defines that inequality. So this is your answer for part A. That's just it. Other than this, nothing else to write. After this, now there's this equation, writing your answer as a polynomial in the simplest format. You just have to simplify it now. Okay, so for part B, fx was given as 3x plus 20, then x plus 6, and then again 2x minus 3. From that, if I multiply the 3x with x plus 6, we get 3x squared plus 18x plus 20x plus 120. And then again, it will be multiplied with 2x minus 3. We'll first simplify this part. 3x squared plus 20x plus 120 multiplied with 2x minus 3. So again, you get 2 multiplied with 3 is 6x squared, 40x, 240, and then again minus 9. So this is going to be x power 3, x power 2, and x. And then 3 multiplied with 3 is minus 9x power square. 60x, 120 multiplied with 3 is 360 minus 360. So we have 6 power 3. 40 minus 90 is going to be 20, right? Sorry, 1 minute. So 40 minus 9 is going to be 31. Wait. 3 with 3 gives you 9. Maybe, I should just start with this one. Sorry, 1 minute. If I just start with, I'll just keep this 3x plus 20 for the left part because they have large numbers to work with. You get 2x square minus 3x plus 12x minus 18. So you get 3x plus 20 and then 2x square plus 9x minus 18. And again from there, 3 multiplied with 2 is 6x power 3. 3 with 9 is how much? 27 x square, and then 3 with 18 leaves you with minus 54x. Similarly, 20 with 2 leaves you with plus 40 x square. 20 with 9 leaves you with 180 x, and 20 with 18 leaves you with minus 360. So in that case, you get 6x cubed. 27 plus 40 gives you 67x squared, and minus 54 plus 180 gives you my plus 126. X, finally you get minus 360. Right? So this is your entire cubic equation. After this, they're saying that the straight line L is a tangent to C at the point where C cuts the y-axis. And the line L cuts C at the point P. We have to find the coordinate of P, okay? Is a tangent to the point where C cuts the axis, right? If C is cutting the y-axis, and exactly at that point they're intersecting. Sorry, this is the tangent. Their tangent over here, and this is the point P over here. I want to find out this coordinate. I can find out this coordinate, but first I have to find out the equation for the tangent. I can understand that if this is an equation for the tangent, I'll first try to find out that intersecting point of the tangent. This is, I'll consider it as M. Okay, where the curve and the straight line is behaving as a tangent, I'm going to consider that as M. For that point, I understand at y-axis, x is always 0. So at y-axis, x is 0. So we get F0, and that will be, this 6 0 power 3, then 67 0 square, and plus 126 0 minus 360. So this value that you get is minus 360 actually. So we get the value as minus 360. Now using this, I can also find out the gradient of your curve. So for the gradient of your curve, f prime x, we get 18 x squared. 67 multiplied with 2 is 134 x, and 126. And now if I just insert that 0, everything will become 0. This will become 0. 18 0 square, 134 0 plus 126. You just end up getting the gradient for your curve. For curve parallel to tangent, since they're both equal at x equals to 0 as your 126. Now you can find out the equation for your tangent. So the equation for your tangent, now you have y plus 360 equals to 126 x minus 0. And eventually you can write this as 126x minus 360. Right, now you can understand, okay, this is your equation 2 and this was your equation 1. If you can substitute them, you'll be able to find out the coordinate of your x coordinate of your point P. So for the final x coordinate of point P, I just have to substitute 1 into 2, and I'm going to get 6x cubed plus 67x squared, and then plus 126x minus 360, and there also I get 126x minus 360. So basically they cancel each other out, leaving you with 6x cubed plus 67x squared equals to 0. And finally, I can take x squared as a common factor, 6x plus 67, 0. So eventually you get the value for x is 0, or the other value is going to be minus 67. by 6. I already know this was the point where the straight line was behaving as a tangent, so I'm not going to accept this. The only value is minus 67 over 6, so which gives you the coordinate of your P as minus 67 as 6. This is the x coordinate. I also have to find out the y coordinate. For that, I just have to insert this into the equation for your fx. So 67 by 6, that leaves you with 667 by, or I can just insert this into the equation for your tangent. It's a small equation. So you get y 126 67 by 6 minus 360. So you get 76, 1767. Oh, sorry. They only asked you to find out the x coordinate. So this was not needed. This part was not needed. So we're only going to write that in that case, px coordinate is just going to be 67 over 6. Right, these are everything you need to do in order to end your question 10. Is this clear? Any problem from this part? Anshat, Arif, any problem?
Sorry.
Okay. If there is no problem, then we'll quickly move on to your last question. Over here, it was already stated, this is your double differentiation, right? So double differentiated, the equation is this. It also states that curve point P has x coordinate 4, and the tangent to C at point P has the equation this. The equation for tangent is given. So we need to find out the equation for the normal of C. I understand that if tangent is parallel to your curve and curve is parallel to your normal, indirectly normal is always perpendicular to your tangent. Okay, so if this is the case, in that case I understand that mn is going to be over here, mt is 3, right? Gradient for your tangent is 3, so it's going to be minus 1 by 3, so you get minus 1 by 3, right? Also, if the x coordinate of p is given as 4, for the y coordinate of p is just going to be y 3 4 plus 4, that's just 12 plus 4 is 16, right? P is a common point because P was the intersecting point for the curve and the tangent. So I can just insert that value for the x coordinate of P into any of the equation. Into the equation for your curve, I could have inserted that. Into the equation for your tangent also, I could have inserted that. But since the equation for your curve is not given, so obviously I have to use the equation for your tangent now. So eventually we get the values that over here, the equation for the gradient for your normal is calculated. The y coordinate for your point is also calculated, and we also want to find out the normal at point P. So for the normal at point P, I have to work with the coordinate of P, which is 416 now. So the equation for your normal, I can now easily calculate, which is going to be y minus 16 and then minus 1 over 3 y minus 4. So eventually you can write this as, didn't give you any format, so you can just write this as minus 1 over 3, 4 over 3 plus 16 turns out to be 52 by 3. So you can write this as just 52 by 3 plus 52 by 3. So this is also by 3x. 1 minute. Right, okay. Now, this was all the things you need to do for part A. Now they're asking to find out the fx equation. Okay. For the fx equation, I understand that this time I do not only have to differentiate this once, I have to differentiate this twice. So first thing, if I want to find out, I mean, again, if the gradient of your tangent is 3, then the gradient of your curve is also 3 when p is equals to 4, when x is equals to 4. So we're going to use this idea. First, in order to find out the f prime x, I have to differentiate the f double prime x. Okay, this is going to give me the equation for your gradient, not the equation for your graph. This gives me the equation for your gradient. So equation for gradient for that curve C. Okay, Now for this one, what was the equation? It was 4x plus x to the power of negative half, right? This is actually 4x plus x power negative half. So if you integrate it, 4x plus x power negative half dx integration, you're going to get what? 1 plus 1 is 2, 4 divided by 2 is just 2x squared, and then again half plus 1 is positive half, right? Yeah, half plus 1 is positive half. So you basically end up getting positive half divided by half. So you can write this entirely as 2 root x plus c again, right? So for this c, I can find out, this is the equation for your f prime x. And I already know that the value for f prime x was 3 when x is equals to 4, right? So we can write that at x equals to 4, f prime x was 3, because we know this from the tangent and coordinate of p. So we get f prime 3, so f prime 4 is going to be 2 4 square plus 2 root 4 equals to, so plus c equals to 3. So from there c becomes 3 minus 2 4 square minus 2 root 4. So you get 3 minus 2 4 square minus 2 root 4, and that leaves you with 33. Okay, so you get the value for your c as 33. If the value for your c is 33, then finally you can also write the equation for your gradient properly. F prime x is actually now 2x square plus 2 root x minus 33. And now in order to find out the original fx, I have to again insert that, okay, fx is actually the integration of the gradient's equation. And exactly at this point, what do we have? We had f prime x was 2x squared. 2x squared is going to be what? 2 plus 1 is 3. So you have 2 over 3 x power 3. Then you had 2x power half. So half plus 1 is going to be 3 by 2. So you get 2x power 3 by 2 divided by 3 by 2. So if you invert this, this is eventually going to be 4 by 3 x power 3 by 2. And again, we had this minus 33x now and plus m. This time the constant, I'm referring that as m, since I've already used c for the previous part. So for this one, now use a coordinate of your c, of your point P entirely. That at point P, the coordinates were 4 and 16. So for this 4 and 16, I can calculate that, okay, in that case, f4 is going to be 2 by 3, 4 power 3, 4 by 3, 4 power 3 by 2, 33, 4 plus m equals to 16. So for all these values, you get 64 into 2 divided by 3. 1 minute. I'll just write this down entirely. 2 by 3 multiplied with 4 power 3, 4 by 3, 4, 3 by 2, and then 33, 4. Over here, you get minus 2, 36 by 30, so 3 plus m equals to 16. So the final value for your m is going to be 16 plus by 3. So you get 284 by 3. So m is by 3. So now you got the final equation for your fx. So fx is going to be 2 by 3 x power 3 plus 4 by 3 x power 3 by 2 means I can also write this as what? This is as root x 3, right? This is also the same fraction. And then minus 33 x plus 284 by 3. And that is your final equation for the fx. This is all the working you need to do for your part B. Is this clear for everyone?
Yes, miss.
Okay,
Yes,
then
teacher.
1 minute.